A cyclist and his bicycle travel at a constant velocity along horizontal road. AI, state the value of the resultant force acting on the cyclist. Okay, we know that acceleration is 0 here. How do I know that? Because the velocity is constant. And according to the Newton's second law of motion, the total force exerted on the system will be equal to A times m. A is acceleration and m is the mass of the system. Here acceleration is 0, so I can conclude that the total force will be 0. I. Copy the diagram and draw labeled arrows to represent the vertical forces acting on the bicycle. Here now the vertical forces acting on the bicycle are mg downwards and also n normal force upwards. Of course, I know that these two forces must cancel each other because the bicycle is in equilibrium in vertical direction. I. Explain why the cyclist and bicycle are traveling at constant velocity. It's very easy because the pushing force due to pedaling of the cyclist and also the resistive force acting on the system must cancel each other. Why? Because velocity is constant. When the velocity is constant, I can write acceleration is 0. Acceleration 0, the two forces cancel each other. B. The total mass of the cyclist and bicycle is 70 kilograms and the total resistive force acting on them is 40 newtons. The initial speed of the cyclist is 8 meters per second. The cyclist stops pedaling and the bicycle comes to rest. I. Calculate the magnitude of the initial acceleration of the bicycle and rider. Okay, the magnitude of the force comes from the Newton's second law of motion, sigma F, of course in x direction, is equal to ma. Here we know that as the cyclist stops pedaling, so the only force acting on the system is resistive force. So instead of sigma F, I can substitute only 40 newtons, and also m could be substituted by 70 kilograms, the total mass of the system. So acceleration is 4/7 meters per second squared. I. Estimate the distance taken by the bicycle to come to rest from the time the cyclist stops pedaling. I use the VT approach. Suppose that this is the VT graph for the bicycle. Velocity at the beginning has been 8 meters per second and it comes to a stop, so it is a line with a constant slope, and the slope is negative 4/7 because the absolute value of acceleration is 4/7. So here I can conclude that this is a deceleration. It comes to a stop. Okay. In this triangle, suppose that this is height and this is base, and base could be taken as t. Here I know that the slope is equal to height, which is 8 over base time, and the slope I know that is 4/7. If I rearrange the equation, I can write t is equal to 8 over 4/7. So here this is the time at which the bicycle will stop, 8/4/7. Okay, the total area under the graph here will represent the total distance traveled when the bicycle stops pedaling to the stop. Here it is easily found by multiplying height times base over 2. So it is 8/4/7. It is simplified like this, 14. So the base is 14 here, and I can write the area will be 14 times 8/2. It is equal to 14 times 4, and it is easily found as 56 meters. Okay. Last part, state and explain one reason why your answer to BII is an estimate. Okay, we know that air resistance is somehow related or dependent to the velocity, and when the velocity decreases, the air resistance is changing, it is decreasing. And so we expect that the total force due to air resistance is not constant. This is the reason that it is an estimate, because it is almost constant here. So anyway, we have taken it to be constant, and all calculations has been done here on the basis of a constant acceleration of 4/7.